Table shows information for England and Wales taken from the UK 2011 census, the number of children aged 5 to 17 and the total population. And then a random sample of 10,000 people in another country was chosen in this year, and the number M of children aged 5 to 17 was noted. And it was found that there was evidence at the 2.5% level that proportion of children aged 5 to 17 was higher than in the UK. But unfortunately, when the results were recorded, the value of M was omitted. So the number of children. And then we're asked to use an appropriate normal distribution to find an estimate of the smallest possible value of M that there could have been. Okay, it's quite a lot to think about here. So first up, the proportion of children in the UK who were children is going to be this 8 million and such divided by 56 million. It ends up being 0.15110, okay, about 15%. So when we construct our hypotheses, H0 is going to be that P is still that 0.1511. And H1, so they were looking that it was found there's evidence that it's higher, so it's going to be that P is greater than 0.1511. So under H0, or assuming H0 is true, we would get that X, this is the number of children with from 10,000 trials were followed by normal distribution, B 10,000 and then 0.15110. But they want us to use a normal distribution here, which means we're using a normal approximation. And we can write down that X is approximately the same as Y following a normal distribution. Now for the expected value, we will do N times P, because it's like remember, P is the proportion that you'd expect to be children. So we just times by 10,000, and then that's going to be 1,511.09 ends up being. Yeah, so I didn't actually include enough figures originally. It's not going to matter. And then to get the variance, this is all in the formula book, you would then times by 1 minus P. And this then gives 1282.75. What I like to do is write it as a square root and then square it. So we're just reminding ourselves we've got our standard deviation in there, the square root of 1282.75. So we know that the probability that x is greater or equal to m, which is approximately equal to the probability that y is greater than m, is going to be less than 2.5%. Because if we just focus on the normal distribution, remember it's centered at 1511 point such and such. We're looking up here where m is, sorry, actually no, m is not there. Critical value is there, whatever that is, and m is going to be inside. We're going to be lower than 2.5%. There's two things to say here. Like, strictly speaking, this is not actually correct. You get away with it on the OCR syllabus, but when you are going from a discrete distribution to a continuous distribution, you should apply something called a continuity correction, because greater or equal to in binomial is different than greater than, but in normal it's not. So you actually have to either add 0.5 or minus 0.5. In this case, because I want to include m, it would be greater than m minus 0.5. I just mention it, if you're somebody who's going on to study statistics, or you're just interested, like, you cannot just go from a discrete to a continuous distribution without any consequences there. You have to do a continuity correction. I'm not going to carry on with it here though. Okay, I'm just gonna, you actually are allowed a range of values for m, so I'm just going to focus on this process. Okay, now I'm going to rewrite. I'm just going to focus on the normal part now and then write that the probability that y is less than m is therefore going to be greater than 97.5%. And now that I've got it as y less than m, I can use the inverse normal distribution. So our area is 0.795. A standard deviation was that square root of 1282.75 mean 1511.09. And we get 1581.28. Actually, that means that m has to be greater than 1581. I've already forgotten what it was. 0.28. So for us, the minimum is actually going to be 1582. Because if you had 1581, you'd actually get something slightly lower than 97.5%. You'd be out of the critical region. The mark scheme actually puts 1581 as the answer, which is, I find it a little bit confusing, but they do actually say that this range is allowed. So don't stress about it too much, I'd say. Awkward question. We got our binomial. We turn it into a normal distribution. We apply this hypothesis test, but we're kind of having to use the 2.5%, do inverse normal to get back to basically what the critical value is. Remember, m has to be a whole number, so we just pick the first whole number that's inside that critical region. And for me, it was 1582.